Okay, so this is Math 110. Everyone who is in the Rome class can go. This is discrete mathematics. Some of you probably know there are two discrete math courses in Bilkent. The other one is 132, and they're very similar courses. 110 is usually offered as an elective for engineers, electrical engineers, and then 132 is a mass course for CS students. And my name is Ergün Yalçın. I usually do this course at least once every year, so maybe I did it 6-7 times. Some of the things that we will be covering is optional, so some of them are my choices. Some of them are part of the syllabus and things that we think you should know as an engineer. This is almost like a mathematics that is not covered in calculus, but you'll be using it quite a bit. So some of us actually believes that you will probably use discrete math more than calculus in your profession. So it's an important piece of mathematics. At the same time, it's sort of nice that you'll be doing counting, you'll be doing graph theory, some of this more aesthetic to some of us, mathematics than just taking derivatives or integration. So I will explain now a few things about what probably we'll do this semester, but generally the idea is that this is the mathematics that you're missing from calculus or linear algebra. I mean, we'll be learning combinations, permutations, general graph theory, and so on. One thing very different with 101 than 132 is that in 110 we try to do more graph theory. So it will be at least 2-3 more weeks of graph theory. And some of the graph theory is difficult, so some people find 110 a little bit harder course than 132. But some other people find it easier, I don't know. But there will be a little more graph theory than the other course, 132. So I'll give you more information about the course, but actually, so this is STARS syllabus from STARS. So I will not distribute this, rather I say syllabus is in STARS, right? And what this syllabus has, usually information about professor. So it has my room number, which you can find, my extension phone number, my office hours, so I should write them maybe. So office hours are on Tuesday, 10:40 or 10:30. But many of you have courses in these times, probably. How many people have courses, classes in these times? Okay, so also by appointment. So appointments, you can take them on Friday morning, 10:30, 11, around that time I'm in my office. You can also take them on Thursday in the afternoon. Thursday 1:30 to 3:30. You can, like Thursday after 1:40 and Friday. These are the days I have class. I have to be in classroom and so on. So that's how I reached. You can reach me. Mm. Course as a textbook. We have a couple of books that we'll be using, but there is one textbook that everything will come from. So the textbook is written in Grimaldi, written in the thing, but it's Grimaldi. So this is the textbook. Good. So Discrete and Combinatorial Mathematics by Ralph Grimaldi. So Discrete Math by Grimaldi. So this is the 5th edition. We have been using this 5th edition for a while. On top of that, it says it's like New International Edition, I think. So, and bookstore has it. This is the one we ordered for you. This is the book that is chosen because it's used in 132 as well, but it has like thousands of exercises. So after each section, you have 5-6 pages of exercise. So it's very useful for that. What we will do, I will give you like a list of suggested problems from this book. I also will give you homeworks from this book. So if you don't have the book, you should have at least a friend who has it. So homeworks and everything will be from this book. But we will also use these 2 other books. So let me write them. So these books are a little bit smaller. I choose them for lecturing, and some of my lectures will be based on these books. If you find these books, you can take them, read them, but you don't need them. These are not like the textbook, so it's like suggested reading. The first one is this. This is by Sheridan and Ross. And this is a very nice book. Actually, if you are interested in discrete math, you can read all of it. Some of the topics we won't be covering, but it's a very nice book to read. It's very compact. And the other book I sometimes use, this is a little bit more advanced, but A Beginner's Guide to Graph Theory. So let me show you that. A Beginner's. By W.D. Wallace. I mean, this is advanced. But when we are doing graph theory, you may need something that you can read just to understand the topic better. But you probably will do first like 60 pages or something, not too much. Any questions so far? Anything? No? Okay. Let's come to grading. Grading is also in the syllabus. So this is grading. So we have 2 midterms. Some of our friends start giving 1 midterm, but I'm not ready to give 1 midterms yet. So I will have 2 midterms, 25% each. And then we'll have final, 35%. Homework and quizzes. Now homework has 8%, quizzes 7%. But the way it's going to work is this. Actually, homeworks will also be quizzes. Will also be quizzes. So you only will get quizzes actually, nothing else. But the way we will do is this. I will assign you homework every other week with 5 questions. And then one of the questions will be the quiz problem for the next class. And I will not collect the homework. Okay? So this is how it's going to work. Homeworks will be assigned, but not collected. Instead, you will have a quiz. Have a quiz on homework. So the idea is that you do your homework, all 5 questions. You learn everything, you study it, and then you come to the classroom next time, and then you solve the quiz problem. Quiz problem, most of the time, like 80% of the time, will be exactly the same. Even numbers won't change. But sometimes I'll change the numbers. Sometimes I may change the question. But it'll be in such a way that if you did the homework, you'll get 10 points from the quiz. So all you need to do is do those 5 questions before the quiz. And then if you're lucky, you could even get away with solving 1 question and not all. But most of the time it's random, so it's better to choose, solve all of the 5, just to make sure. Now the quizzes, these quizzes are the rest. These will be, so this 7% will be only attendance quizzes. So what's the attendance quiz? So attendance quiz is the quiz that the only thing you need to do is write your name. Okay? There will be no question, nothing. Just write your name and you give it back to me. And these attendance quizzes, which will be given only when half of the class is missing. So anytime half of you is not here, you'll get a quiz. So count the days that other people may not be coming. Actually, a lot of people did that. So some of the days, like just before the Bayram, sometimes we have 60 people in classroom because everybody thinks that other people won't come. But this is the rule, okay? So you'll never get an attendance quiz if you are more than half. Okay. So these 2 rules. I don't know. Any remarks, any suggestions? You want to change one of the rules? Something different? Okay, so since you have almost full class here, 35, I should tell you, general rule to pass this course or get a very good mark is to come to the classroom. My midterms or finals are very close to class coverage. So we'll be mostly asking questions that are already solved on the board or just discussed very thoroughly. So if you know what's going on in classrooms, like when I solve a question on the board, if you understand it during the class, then you will probably won't even need to study before the final or before midterms. You just need to know these questions that I solve on the board, and at the time ask questions and learn it. So if you come to the classroom and just be attentive in the problem-solving process, if you understand the solution, then you should be fine. So because of that, I can put more rules. I can say, if you don't come 70%, you get F. I don't put those things, but essentially the idea is that you should come to the classroom. If you don't, I mean, most of the people who don't come to the classroom gets bad marks. And you already know it yourself, probably. The correlation is so clear that we know it, that who doesn't come to the classroom always gets bad marks. So come to the classroom, okay? And ask questions if you have questions. Okay? Okay, so more. Okay, I mean, in the meantime, I will try to get you talk more, but so far this is the thing. Our classroom will be here because, as you notice, they're recording us, and this is for the Beekland University archives. So we will not be using the other room, but here. So classroom is always here, every week, every day. And I sent you email today. That is how I communicate. I like to send emails rather than making web pages or other things. I don't know. I think many of the people nowadays check their emails at least once a day. So it's the direct way of reaching to you. That's how I think. I find it very easy to write emails. I write like 20 emails a day. So I will communicate with you through email. So make sure you look at your email time to time. So for example, I will send you a list of suggested exercises. Say tomorrow. On the weekend. So I used to bring it and distribute it, but this is the time. Like nowadays, what I do is just send the email with the PDF attachment, okay? So that anytime you need, you can look at it. If we send papers, people usually put it somewhere and they lose it the next day. But if I send you a PDF file via email, you can save it and keep it until the end of semester. That's the idea. But if you lose these emails, you can ask me again to send you one more. But I will send you a PDF file with some problems. Also, I assign homeworks only in class. Although I do this via email, homeworks will be assigned only in class. So if you email me, I may not send you this homework assignment. I will not give you questions for the homework via email, okay? Only in class. So you have to come to the classroom to take your homework assignment, and then you have to come next time to take the quiz. So you have to come every week. That's the idea. Okay? Any questions? Anything? Good. There's one more issue about grading. In the past, I did this, so you should know that. Hopefully, we won't need it, but if you feel like towards the end of the semester, you're getting a grade from this course lower than you expected, like you're really heading for a D or F, you just want a little bit lift, you can do a verbal presentation. To ask for extra points. So the verbal presentation, you will come to me, say I want to do this, and then we'll talk about the topic you can do, and then it will be presented in the last week of classes. So it will be a 30-minute, 20-minute presentation in front of the class to your friends, and then according to the reaction you get from them, I'll give you an extra point. If you do a very bad job, you may get no extra points. So it's a risky thing to do, but if you want, like, instead of getting an F, you want a D, this is when you ask for it. And then you do something, and then you may save yourself. But after the final is given, we will not talk about grades. So that's when it's finished, okay? So if you want to save yourself, you see me like 3 weeks before the end of the semester, okay? So come talk. 3-4 weeks before the end of semester. Okay, and actually these verbal presentations has been fun in the past. Some people did very good job explaining me how they use discrete mathematics in their profession, what they want to do in the future, what they can do with discrete math. We discussed some graph theory. We discussed these problems of 6 degrees of separation. We discussed some Facebook graphs, many interesting mathematics that's used currently in real life. Some people talk about coding, how you can use prime numbers to code. So many cool applications. I will try to tell you some of them, but essentially, sky is the limit. There's so many interesting things you can find to present that I won't even tell you do this. I mean, you probably will find them yourself. I mean, this is really the mathematics you see here is the mathematics used in many areas. And one last thing, I guess, for FZ, I put it in the internet too, stars. You need to get, to avoid FC, you need to get more than 20% average from midterms, okay? Yeah. So to get FC, you need to be smaller than 20% average in midterms, okay? It should be less than or equal to 20%. It's very low, partly because I want to give you another chance for the final, but passing grades will be much higher than that. So in the past, 35, 40 was passing grade, I think. So you need to do more than 20%, but FZ is usually much lower than that. Okay. Usually people get quite a bit credit from homeworks and quizzes, so if you 15%, if you add it, usually it pushes to the 25, 30. So with the final, 35% is, 40% is passing grade, usually. So you may wonder about this too. Your letter grades will be determined by some sort of distribution of the classroom grades. So you'll look at it, and some people will get A, some people B, some C, and so on. So there's no predetermined catalog, anything like that, okay? So if everyone performs bad, overall letters might be a little low, but still the top people will get some of the better grades. It's not. So I'm also hoping that you perform good, right? Everyone gets 90s and so on. But in case you get all bad, we'll adjust the grades, okay? Not everyone gets an F. Okay, one last thing. I have to say this too. So midterms, they will be in 6th week and 12th week. Now, according to calendar I looked at, on the 6th week, we can do it on Tuesday lecture or on Friday lecture. And on the 12th week, I think because of the Labor Day, we better do it on Tuesday. I think it's school is off on Friday that week. So this has to be on Tuesday during lecture. But maybe I will try to get a bigger room or something like that. The other one is Friday during lecture. Other alternative is to do is on the weekend. So if we have trouble getting rooms, we may have to do it on the weekend. So how many people will prefer a weekday in-class exam? Or so if you prefer weekday, raise your hand. Okay. If you prefer weekend, raise your hand. 1, 2, 3. Okay. So there is a little bit tendency towards the class exam. So we'll try to lose only one hour. So if we do it on Friday, we'll still do 2 hours on Tuesday. Okay. So the plan is we always have 3 hours a week. So use the 1 hour for the exam, so that we'll lose only 1 hour. And depending on the end of the semester, we can even make up that. But the 1 hour is usually not a big deal. The reason is that on the 6th and 12th week, there's calculus exams, and they usually use 40 rooms. So we won't be able to get rooms, I think, on Saturday morning. But maybe I can try Sunday morning. If we want, we can. And let me work on that. But just mark it on your calendar. These weeks, you will have exams, okay? So that's the plan. Okay, so seems like no more questions. We can start. Let me give you a little bit, maybe, to excite you a little bit about the course. So, I mean, depending on what you were expecting for this course, this could be the most exciting course you took, or this could be the course you want to forget. So let's see what is in the menu. Let me go through some of these course content. So the plan is, this is the syllabus still, to start with some notations, basically, and then to do what we call mathematical induction. So we'll start talking about this actually today, because now we have 2 hours, so we'll talk about this. But this is essentially just verifying statements that involve some natural number in it. So you have something like, is it true that 2n is bigger than n squared for all integers n, say bigger than some number? So this kind of statements, there is an argument called mathematical induction. Actually, it's a proof, mathematical induction, proof by mathematical induction, that verifies these statements for you. Once they're verified by using these arguments, you can use these inequalities or facts. So, for example, some of you probably know, if you sum the numbers 1 to n, you get a formula, right? So what's that formula? Anyway, n times, yeah, n plus 1 over 2. So maybe we will verify statements like that, why this is true for all n. So we'll talk about this. But the reason actually we're doing this mostly, in graph theory, we have a lot of statements that involves big n's. Like you'll be dealing with a graph with 5,000 nodes. So big N graph theory statements sometimes will be proved using induction. So if you get used to mathematical induction from these baby examples, then you can use them when it gets more serious. In graph theory, we have some really nice statements, very, very difficult mathematics. All you need to do is verify them using induction. Then induction gets a little bit harder. But if you have some experience with induction, using these toy examples, you find it easier to use it there. So that's why we start with this, and you need to know it. Right? This is one of the most important tools you'll be using. Like in graph theory, you have a big graph, say planar graph, and you will be having statements like saying that number of vertices minus number of faces, edges, plus number of faces is 2. So you'll have to verify such statements for any graph. And now we'll say, okay, this is any graph. And now we'll say, let's make one less edge. So you'll do induction on number of edges. Or say, let's make one less vertex. So you'll do induction on number of vertices. So induction will be used to study graphs or things like that. So that's why you learn it. I'll describe it in a few minutes. But so you see, it's not going to be only these toy examples, but you'll have more advanced things. So the other thing you learn some number theory. Number theory, again, you learn it very simple level, like things like division, primes, Euclid algorithm. This will be to make you more accustomed to numbers, their behavior in terms of division. Again, the engineers use these kind of things all the time, like prime numbers is used for coding, and some of the algorithm writing involves divisions, algorithms. So this is for finding the common divisors, greatest common divisors, the fast algorithm. So it's a useful piece of mathematics. Especially prime number discussion, you could make it very advanced. Like you can talk about it. There's some very advanced things involved there. Again, the level of advancement, how far we go in there, will depend on your interest also. We'll see. Now, discrete math is mostly about counting, to my opinion. So we'll start doing counting. This will start with things probably you know. I mean, I haven't asked you this, but which year you are at? Like how many people is fourth year student? Fourth. How many third year? Okay. Is there any second year? 2. Okay. So third and fourth year, this is usually what we have here. By this time, some of you probably took some courses that involves counting. Probability. How many people took probability? Okay, so you'll be familiar with this. But what we will be doing here is not just the formulas, but the act of counting. So we'll be looking at how you can use just the bare logic to count things. So the basis of counting, like not just formulas. Of course, we'll derive formulas, like there will be permutations, combinations. This will come up, which you probably know. But more than this, like we'll look at counting as like, so how you count something, you'll be looking at product rules. Like if you have things happening in a consecutive way, we'll be multiplying number of ways to do them. When they're distinct, we'll be adding. So the basic rules of how you count a set, we'll look at the heart of the matter. And again, this will change the way you think. That's the idea. So when you count, you will not be using just the formula, but you will be sort of using intelligence, basically. You learn the intelligence of counting. Okay? before maybe you just learn the formulas, but we'll be looking case by case and analyze them. So it will be things like that. So it involves, for example, what we call inclusion-exclusion principle. This is essentially like how you count union of sets or sets outside of union of sets by just knowing information about number of elements in the sets or in their intersections. So there's a formula which tells you how many elements in a union in terms of the elements in the sets and the intersections. And it's a very complicated formula actually. So we will come up with this inclusion-exclusion principle. From that we'll learn stirring numbers, I think, but a little bit maybe later. This will be number of surjections. But then we'll see that in daily life, you actually use a lot of number of surjections in a function. So it will be something that you don't know. Like you will recognize these maybe, like 5 choose 3. But then stirring numbers will be a different family of 5 choose 3s. So it will be all different. There will be number of surjective maps from, I guess, 3 to 5. From a set with 5 elements to a set with 3 elements. How many surjections do you have? Very simple question, but very complicated formula. Actually, if you can figure out 5, 3, how many surjections you have from a set of 5 to 3? Surjection means all the elements should be taken. Everything should have something coming towards them. So how many surjections you have from 5 to 3, if you can figure it out by the end of today's lecture, I would like to hear if you can find it. I mean, it's hard. It's not easy. You find it later. So we'll have a different, we'll have a formula for stirring numbers n and k in general. We'll develop that using inclusion-exclusion. So it's a very nice, fun story. Then midterm 1 will hit. So somewhere here you'll have midterm 1. And then we'll start after midterm 1. We'll have a slow start probably with pigeonhole. Pigeonhole principle is also a very nice principle, but it's very hard to apply in problems. So you may find it challenging to discuss. It's essentially the principle that if you have pigeons and pigeonholes that pigeons go, if you have more pigeons than holes, then at least one of the holes will have more than one pigeons in it. So this will be the principle, but you will see so many difficult problems that will reduce to this simple principle. And you will be able to solve very difficult questions using this principle. So that's the idea. Then you'll learn graphs. Did we pass over time? Öğleden sonra 40. We have 4 Ds, right? So 10 more minutes. Okay, let me finish this and then we can take a break. Okay, so we'll start graphs. How many people heard graph as a word? Graphs? 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 Did you take courses or just heard it? Anybody took a course on graph theory? No? Okay. So graphs are basically vertices and edges between them. And it's used a lot. You can use it as in Hasse diagrams, or you could use them like this. It could be like this. Sometimes you have multiple edges between vertices. But it's used to record the information of like certain nodes and their interactions. So in daily life, this happens a lot. Like you have say, IGAS. IGAS has all these buyees, right? These are IGAS buyees, and some of them are connected with each other by certain truck going between them. So you have a graph of your buyees and their connections. You draw the graph, and sometimes you ask very simple questions that in daily life you need to know. Like you want to go from here to here, which path you should use with lowest cost. So sometimes this will have also weights, different cost. So you will be using minimal cost path, for example. Or you could try to find a subgraph of this called trees, where trees is a special form of graphs which you are not allowed to do these kind of loops. So these are not allowed. So in a tree, you never have a closed path. So it has to, they look like this mostly. And then you find what we call a minimal spanning tree, which is the subgraph, which is a tree which has the lowest total cost. And then we'll discuss algorithms of finding such minimal spanning trees. And we'll have like 3-4 different algorithms. We'll compare these algorithms. Some algorithms we'll find more efficient. We'll compare their speeds and so on. One of them is called actually greed algorithm. So they have some funny names. But the discussion will be always towards solving real life problem. But we'll abstractly state the questions here, like find the minimal spanning tree. But in the behind, you'll always see that, oh, this could be a graph of Facebook people with friends, right? So graph theory is the mathematics that becoming the most important mathematics, because we have so many webs of, I mean, World Wide Web is also a web. So these are all, information systems. Everything is about graphs now. So anyway, I can state you more cool problems, but like Königsberg Bridge problem, we will look at it. We'll be looking at problems where you'll be required to pass all the edges of your graph, but you will not be allowed to repeat an edge. So you'll be asked if you can find such a path where you will not be repeating any edge. You'll not be passing through an edge twice. So some graphs will have it, some of them will not. And now you will have criteria for such paths to exist. Those are called Euler circuits, and we will look at Euler paths. So we will have some interesting problems. So basically, so we'll discuss these Euler graphs, where you will be passing through the things. Maybe we'll also discuss cliques. Click in Turkish, like click oruç, and in Turkish also they translated it directly, but in Turkish it's called hizip. Maybe that will make more sense, but this is called hizip. So it's a group of vertices in your graph where they're connected to each other. So for example, this is a clique of size 3. All of them are connected to each other. So you'll be looking for cliques in your graph with maximal size. Like I can make it bigger. Say, suppose you have this. Now you have a clique of size 4. So clique is, you can see from the Turkish word two, is a bunch of vertices that any two are connected with the edge. And finding the maximal size clique in your graph is a very well-known question that you analyze in a graph, and then you compare it with independence numbers, and you have formulas and so on. So degrees, for example, we'll define a concept of degree of a vertex as the number of edges attached to a vertex. So degrees of each vertices will be an important data that we'll keep together, and then we'll use that data to analyze how big your cliques are. So there will be correlations between degree or independence number and so on. And finally, let me say one more thing, give you a break. Here midterm 2 will hit. Usually we stay in time, so I'm pretty sure we'll do this on time. So we'll discuss, after that, we'll discuss generating functions and recurrence. So these generating functions and recurrence relations usually are more fundamental in 132. You spend sometimes a month on it. But here we'll be doing them in 2 weeks after midterm 2. So what they do, they help you to understand sequences, find formulas for sequences. If you just know formulas for a relation for different shifted terms of it, like an, if you know an in terms of an minus 1 and then an minus 2, and then some initial values for a0 and a1, then you can find a formula for an in terms of n. So these formulas come out of studying generating functions, and you can sort of you can develop algorithms of how to solve these recurrence problems. And this is called the second degree recurrence because you only have two things. We'll only be solving second degree ones, but with the understanding of generating functions, potentially you can solve higher recurrences too if you analyze them well enough. Some of the famous examples are, say, Fibonacci sequence and things like that. So we'll be talking about sequences, but in a discrete mathematics way. So we will not be doing infinite sums or limits or convergence or anything. So this is the course you will never hear continuous function. You will not hear limit. You will not hear derivatives. These are calculus topics. So this is the course that is discrete. That means everything will be sort of partially like discrete. Okay, that means that you'll be counting finite sets. You'll be looking at graphs. You'll be analyzing a situation. So you'll not be using derivatives or integration or anything. Okay. So we take 10-minute break now. After the break, I will start with this topic. I will introduce the notation and mathematical induction. Okay.